This video was shot in the fall harvest of 2017. We're looking at a Hagee 472 high clearance machine with a 6-row deheader on that we use systematically to dehead our crop every fall. We do 2 deheadings. We do the first deheading in normally mid to end of August, at which time we'll have maybe 90% of the heads emerged. We do a second deheading just before the harvest. By doing this, we've been able to prevent wind loss. This last fall, we went through 45-mile-an-hour winds with no loss. Typical fall for us will have one day with 60-mile-an-hour winds. Ever since we've done the deheading twice per season, we've never had trouble with wind loss. You'll notice right now we're opening up a field, so we're not completely taking all the rows. Here we are, we've got the whole works. You can move along fairly rapid, 2 to 3 acres an hour without any trouble. We don't get all the heads, but we get enough of them to prevent wind damage. You'll notice that when we started out we had a face shield and a dust mask. That's pretty essential because of the pollen. 5 years ago we decided that we would build a self-propelled harvester that would be capable of squeezing in the field and handle the muddy conditions that we have a lot of times at harvest. This is built on the 4-wheel drive chassis of a 6600 John Deere combine with a diesel engine and a hydrostatic drive. We've got a 3-row uni harvester head in the front. The press in the middle of the machine was custom built. We designed and built it. All the white components that you see there are the cement drive out of a concrete cement truck that drives the press, and the juice is squeezed out, filtered, and then pumped into the 1,000-gallon tanker that we have behind. Shown here is the concrete drive on the side of the press. It came out of a 10.5-yard concrete cement truck, has a speed range of 0 to 13 RPMs in either direction, ideal for running the press. You'll notice the hydraulic cylinders in the front there to close the press down. We can put 100,000 pounds of pressure on the top rollers. Pressures for both the pressure on the pump and on the cylinders are read up by the cab, so we know exactly what we're loading on the press. Another view showing the shafts. We have a reverse drive on the front roller that runs a scraper that runs underneath the rollers. This is a one-man operation. We do not have to have somebody behind to scrape the junk off. The juice filters through this automatic scraper and then is pumped for the diaphragm pump up to the tanker behind. Just another view showing the press. You'll notice the chain drive that's running the scraper that's underneath the press. You'll notice the catch hopper in the back here with the safety sign on. We lift that out of the way to get to our scrapers to service the unit. The shafts in here are 6.5-inch diameter shafts. The rollers are 16 inches by 22.5 inches wide. They've got 1.25-inch deep grooves every inch. They weigh 1,290 pounds each roller. The frame is made out of 1-inch plate steel. The bearings are a brass, bronze, lead combination that will withstand high pressures, misalignment, and very poor lubrication. We had considerable amount of problem in the first 2 years with bearings until we redesigned the bearings. Notice the gears on this side, they're 6 inches wide. They're designed so the rollers can open and close. Below the gears is a diaphragm pump. The diaphragm pump is run with a hydraulic motor, ideal because it never back sucks out of the tank. It will prime itself every time it runs out of juice. It will reprime, so it's been very effective for us. You'll notice to the left top of the picture with the steel plate with the adjusting screw, we can move the rollers and coordinate them to each other to how much pressure we want between the first one and the second one, or the top one and the third one. We've got a 3-row uni harvester head in the front. Not the best head for that type of an application, but the one that was most available to us. We're in the process of doing some redesign on not only this one, but also building our own special head. We found that because of the amount of juice that we're getting, The most effective way of using this head is actually one row at a time. It brings it up on the side, kind of drops it down into the center and feeds into the center of the machine. This picture doesn't show it, but later in the season we added a PVC tubing to give a more direct feed to where we want to. We're doing around 350 gallons of juice per hour on the average. You'll notice here the rollers that are on top. There's a reverse drive in that picture to show that changes the direction of the chain such that the rollers will coordinate with the bottom feed conveyor. This view shows the other side of the machine with the drives that run the head. You can see the arrangements of chains and belts that we had to use to slow it down to get it coordinated. Behind the head here is actually a conveyor that goes through the center of the machine that feeds the press. We haul the juice home and we unload it through a screen before we pump it into the building. That picks up the initial seeds and stuff that might actually be in the line. We've got a large capacity, about 250 gallon a minute pump that we throttle way down, pumping the juice in. It goes into a preheat. We heat it up to 200 degrees. We hold it overnight, and then in the morning we drain the junk out that's in the line, and then you notice the clear stuff coming. That will be what we'll pull off. That runs up into a 600 gallon tank with an agitator, and at that point we'll add the filter aid. You notice with the clear lines we can watch at the end of the time when we're pumping the juice out of the tank. We're looking for the clouds. When the clouds start to come, that indicates that it's time to stop pumping. This is the filter aid going into the tank. We're still probably 160 degrees in the juice at this time. This is the filter press. We're running it with a diaphragm pump in the lower left-hand corner. The filter press consists of papers between plates, and it filters out the filter. The juice from the filter press is pumped into the tank in the top left-hand corner. We run it into this tank, which is our first tank of the continuous flow system that we use by using just 2 pans. You'll notice that we turned the air on here. We have air injection. There is no heat on this pan. This is simply the air causing the bubbles at this time. The next scene here will show us with steam on only. We're dropping off now with the air. You'll notice the steam in the back end of the pan where it's boiling. Pretty quick, I'm going to turn the air on. I'll show you what it does. That's the way we cook. We use very little heat on that pan. A lot of evaporation is taking place by the air bubbling. That pan actually is operating around 180 degrees. And we're getting very high levels of evaporation off of that pan with low heat. From this pan, it flows into the second pan, which is a Stubbs pan. We come into the wide side of the pan, make the bend, and come down the narrow side to do our finished syrup, and we'll see that view once we jump over there. Another view showing the first pan and the cooking that we're doing with the combination of heat and steam. Notice that we've only got a little bit of skimming on this end. Because of the filter press, we never have any green skimmings. You remember Warren, who used to come to convention with me here. This is a view of our high-pressure steam boiler that we run outside the building. We run 20-some years on wood, and this year we converted it to fuel oil. You'll notice there is a Carvel 2-stage oil burner on there. We can burn up to, last year we burnt 14.5 gallons an hour max. This year we're going to kick it up to burn 20 gallons an hour capability. We've got a 500-gallon fuel oil barrel behind us there that they can fill from the road to give us our fuel. The steam is doing all of the preheats and all the cooking by coils in the pans or in the tanks. We kick a lot of steam out. You don't see the steam in the buildings a lot of times as much as you do outside when it gets so cool. Warren is watching the temperature gauge right there now. He's still in the startup process trying to balance the pans out. You'll notice the juice sitting on the right hand side of the pan coming from the preheat pan and the cooking the syrup on the left hand side. This is the final syrup coming off. Brenda's running it, watching the thermometer, balancing that against a Brix reading on the refractometer to know when we're taking the syrup off. We're running through a filter and then a pump, and it's going up through a cooler and coming back down into, this is a pail right here, but a barrel normally. We hit the barrel at about 120 degrees. All of our sorghum is stored in 55-gallon barrels, so throughout production we only fill barrels, we don't bottle as we're going. So this would basically give you an overview of what we're doing. I hope you've enjoyed it as much as we did, having fun doing it. Thanks to John and to Jake who helped put this together, John who shot the field scenes, and to Jake who did the video for me. I appreciate it very much.